Welcome to our demonstration for the project Elasticsearch for Sparkler. This is the first part of the demonstration where I will show the Solr storage backend. As we mentioned during the presentation, our project initially had Solr as a backend implemented, but we will also show it during the demo for two important reasons. First of all, we made significant changes to the code base when introducing the factory implementation. We want to show that the existing Solr implementation still works as intended. Also, we want to show you the data in the Solr database to show, so you can see that it's the same between Solr and Elasticsearch to verify that it works correctly. Let's start by starting Sparkler using a script. It will start Sparkler and Solr in a Docker image. This will take a few seconds until Solr and Sparkler come up, which now happened. And now if I open Docker, you can see that it is running. Now I can show you the Solr admin dashboard where we just query for the whole data. I can just click execute query, and as expected, the database is currently empty because we haven't done anything. So let's start by using Sparkler. So the first step for web crawl is to inject the seed URL. The seed URL is the URL which the web crawler visits for the first time and starts a crawl process. You do this with the command inject, then you need to give it a unique ID. In this case, it's 1, and this just mentioned seed URL. We're using cnn.com. So this will be saved into the database as a starting point for the web crawling process. Let's execute this. This only takes a very short time. Now it's done, and we can go back to the Solr dashboard, admin dashboard. As you can see, CNN has been added to the database, and the status is unfetched because it's just been added to the database, but the crawler hasn't actually visited this website yet. But now, when we run the crawl process, it will start at cnn.com and look at the content of the page and all the outgoing links. So let's do just that. When we run the command crawl, then we also need to give it the same ID as we used for injection. So 1, we want to show at max 100 results, and we want to do 2 iterations. Because this is a recursive approach, it will visit all the links on every page it sees. We need to stop it at some point. We choose 2 here because it runs relatively quickly for this demo. So let's execute this. So you can see here the crawler starting to visit the website and save data to the database. This only takes a few seconds. Right, it is already done. Now we can back to the dashboard. As you can see, the dashboard changed. We have 98 hits, which is good because we wanted less than 100. And this is the original entry we had. The status changed from unfetched to fetched because the crawler visited it. As you can see, it visited many more pages and also saved the content and outgoing links. Now I'm handing over to Kevin to show the Elasticsearch part of the project.
Got it. Thank you, Felix. All right. So for part 2 of the demonstration, we'll be demonstrating the new Elasticsearch pipeline that we introduced. So first off, we need to go to our config file to specify which backend we want to use. Here I am in Sparkler, Sparkler core, conf, and here we have a sparkler-default.yaml file. Under general properties, we have a crawldb.backend. Here we can see it's specified to Solr, but now I want to change it to Elasticsearch. Now, normally changing this will require rebuilding the project, but I did that in advance. You would run a Maven clean package, and this can take about 2 minutes. After that, we can bring up our Docker containers. I brought that up in advance as well, and we can see we have 3 containers. Here we have an Elasticsearch instance, a Kibana instance, and a Sparkler-Elastic instance, which is our Sparkler instance. So if we go to localhost 9200, where Elasticsearch is, you can find that Elasticsearch is already up. So if I go back to my command line, log into our container, I can then begin injecting again. Here I have an injection command. We're injecting cnn.com. All right, for this, we can now go back to Elasticsearch And for those of you who have some experience with Elasticsearch, we can go to our crawlDB index, which holds all our crawl information. You can see here that we have one hit, and this is our URL cnn.com, and we can see our status is unfetched. This is our CD URL that we just injected. Now, to compare this to Solr's, here we have Solr's. The information is the same. Now that we're done with injection, we can now go back to crawl. We can take our crawl command. We're once again crawling on the same ID, and this will spit out output for the crawl process. Okay, now going back to Elasticsearch, we now have a lot more information. We could see that we have 98 hits, which is good because we specified no more than 100. And now we can see our seed URL is having status of fetched. We also have outgoing links and scraped information down below. Now to compare this to Solr's, you can see that the information is the same. All right, that concludes the crawl process. To clean up, we will be bringing down our Docker containers. To do so, we would exit out of our container and then bring it down using the --down. All right, to sum this up, we successfully created a new pipeline for data persistence using the Elasticsearch storage engine. We have scripts for bringing up and bringing down our 3-container system. We have introduced significant abstraction into the code and worked directly with many distributed computing components in order to redirect data to either Solr or Elasticsearch. And the final data we insert into the storage engine is consistent between both Solr and Elasticsearch, providing assurance that our progress was effective. And to close this off, we would like to extend another big thank you to everyone involved in the making of this project. Thank you.